Okay, hi. I've been around for a couple of days, so some of you already know me, but I haven't had the chance to meet all of you. So I'll introduce myself formally. I'm Sebastian Canevari. I work with all of the escalation engineers. I'm, of course, an escalation engineer, right? To work with the protocol specification group. We help you guys when you are having issues with the documentation. If you reach us by doc help or by creating a forum post, it's us that will respond to you and start working with you on the cases. The main job that we do is to be like an interface between you and the product group. We try to be the ones resolving your issues. Sometimes we do have to escalate. That sometimes happens. So we tend to be the front line whenever you have a question or a problem that you need to work with. When we started talking about the presentation, we were thinking about creating a exclusively debugging presentation. But like all of you know, in 1 hour, you cannot learn debugging. And even though if you do know debugging, you cannot learn to debug a specific system in 1 hour. So it didn't make much sense to just talk about debugging. So we decided to go more towards what tools we use and what tools you can use in order to troubleshoot SMB issues, or mainly any kind of issues with Windows. We know that generally you come from an environment that's not a Windows environment. So some of these tools that may seem very common to us and we use them every single day, we know that maybe you don't even know that they exist. And they certainly save lots of time sometimes when we're working on a specific type of issues. We're going to be talking about different types of tools we use. This is the agenda. So that was kind of the presentation. Now there's going to be an introduction on what we're going to see. We're going to talk briefly about Netmon because you've been hearing a lot about Netmon and you've already been working with it. We're going to see some of the debugging tools for Windows. That includes WinDBG, which is our main tool. Time travel tracing, I don't know how many of you are familiar with it, but this is probably one of the most powerful tools that we have in order to troubleshoot user mode issues. And you'll see that it's extremely helpful and useful. ETW tracing, that's something that you've probably been working with too. And I'm going to show you how we can somehow match a network monitor trace with an ETW trace. Windows Resource Kit tools and sysinternal tools, those are very powerful small tools that we generally use a lot in our day-to-day basis. So we're going to just show a couple of them, but of course those are a couple dozens of tools that we could potentially be using. I'm going to show all of that or somehow integrated. Some of the things are going to be live. Some of the things I've already recorded in order to be able to save some time. And then, of course, it's going to be a Q&A that I hope I can answer lots of your questions. So when we're working with wired protocols, the most common thing that we're going to be using is Netmon. And Netmon generally saves our butts in 80% of the times, right? If we need to know if Netmon or Wireshark, let's assume that some of you use Wireshark. So this type of tools are, of course, give us all the information that's on the wire. And if we know what we're looking for, that's it. I mean, we see it on the wire, we know what it is, and we know if it's right or wrong. Of course, sometimes we need to go and look from a different perspective. Let's say that we have something that's encrypted, and we don't have a tool to decrypt that from the wire information. So what do we do in that case? Sometimes we need to debug on the user mode. Sometimes we need to debug on the kernel mode. Some drivers encrypt. Some user mode processes encrypt. So we need to know how to get that. When we don't have the chance to look at the problem live, we have the help of memory dumps. We have the help of time travel tracing, which is one of the tools that we're going to be showing. ETW. Those are tools that help us save a log that's going to be completing the information that we have from Netmon. The truth is that 80% of the time, Netmon solves it by itself, and the other 20, you will need a Netmon trace one way or the other, because this is wired protocols we're working with, right? So this is kind of what we're talking about. The netmon presentation that you've seen a couple days ago show you that most of the protocols have full parsers already available in netmon. All of those parsers, like Paul Long was saying, and you've heard on enough this couple days, have been based on the WSPP and MCPP protocol documents. So what it is on the document is going to be on the parser. That's 99.99% of the time true. Of course, there might be bugs on the protocols. There might be bugs on the documents. There might be bugs on the parsers. Those cases are, of course, possible. So that's why I say 99%. But most of the time, the parser is going to be matching the document. So whatever you see on the wire, be almost sure that that's what you're going to see on the structure when you go into memory or whatever, and that's what you intended to do too. So if your system is sending something wrong, it's likely, if you see that like your system is sending something wrong on the wire, it's likely that the system it is sending it wrong. There are several experts that you can add. I believe some of you are familiar with nmdecrypt, which is the tool we use for SSL decryption. Like we use SSL for many other protocols, sometimes nmdecrypt is very helpful to troubleshoot some other type of problems, like for instance, SSTP. I've been working with SSTP cases last couple of weeks a lot, and nmdecrypt was a huge tool for me to be able to decrypt what was on the wire. Top users, it's another very useful expert that you can use. When you want to see what experts and parsers we have, CodePlex is the best place to go after. If you get into CodePlex and you look for experts, you're going to find a whole bunch of them. There's some that are very, very useful and some that are very specific for very specific type of issues. That's going to be up for you to look. Now, at the same time, CodePlex is a shared development environment, right? So you can probably help yourself and some of your peers if you work on a expert that you really think that is going to be useful, and that's the perfect place to go to, right? To publish it in CodePlex so everyone can use it. Debugging tools for Windows. Of course, there's many ways to debug, right? I mean, we have the KBD, we have different Visual Studio or other development environments that help us debug. The one that we use the most, in my case, and that you can use too, is WinDBG. WinDBG is our GUI interface, and it's extremely powerful. There's tons of features you can set on it. There's tons of features you can add to it with add-ons that you can include in WinDBG. It has the ability to do user and kernel mode debugging. Of course, you have to set the system in order to be able to do that. From Windows 2003 on, and if someone knows if I'm saying this wrong, please let me know. But I don't recall if it's 2003 or 2008. You can do local kernel mode debugging. So you can hook into your local kernel and debug it live, right? Of course, there's certain restrictions to that. You can not stop LSAS, for instance. That's going to reboot the system, right? But there are certain kernel drivers that you can actually debug locally, which is very powerful and very interesting. When we're working with your type of cases, sometimes we ask you for a memory dump. And the reason is because for us, sometimes it's not possible to do a lab debugging. And of course, sometimes it saves time not to even try it, because we need to set up the environment, we need to log into your environment, do the live debugging, use the right symbols. So sometimes it's a little complicated. So when we use the memory dumps, we can do the post-mortem debug, and if we bring that to our network, we can use our local symbols that sometimes help us a little bit more, right? The private ones are a little bit more descriptive. Also, WinDBG allows us to use time travel tracing. Time travel tracing, as you're going to see in a couple slides, it's, like I said, a very powerful tool, allows us to go back and forth on a dump, like if it was a live debugging. And that's very, very interesting. When we're debugging saves SMB, SMB2 issues, Usually, we're working both on user mode and kernel mode. The drivers, of course, are all in kernel mode. And lots of the action for SMB happens at the driver level. So we need to do kernel debugging. That's why sometimes it's important to have the full memory dump, right? Because that's when we have the kernel and user mode information, and that's when we can look into SMB issues with post-mortem debugging. In the user mode process, the workstation and server service are very important for SMB because those are the entry points for the communication. And LSAS is a security subsystem, so you're going to see during a security handshake, like a session setup, you're going to see that LSAS is in the middle of it. It's going to be using the tokens of the users and stuff to access the information needed. WinDBG, it's extremely documented. The help for WinDBG is probably one of the best helps I've ever seen. It has every single command, every single parameter you can use, lots of tips on how to debug, lots of tips on how Windows is doing things, what we're expecting from the client, from the server. It's a very, very, very complete help. So if you ever start working with it, trust me that hardly ever you will have to go out of the help from WinDBG. I know that's not common for most of the tools and programs, but this is very true for WinDBG. There's 32 and 64 bits versions. There's symbol packages you can download to save time of downloading. We have a symbol server that it's publicly available, and those, of course, are the public symbols, and the information that they provide, it's quite good enough for us to troubleshoot. So most of the time, we don't even need to use the private ones. When we do need to go into code and match code, we do use the private ones. But when we don't need that, it's almost all we need to use is the public symbols. This is the link to get them. This is the updated link. Of course, you can just go to any search engine and find it. I believe these PPTs are going to be available later, so you can, yes, they're going to be available later, so you can download them and just click on the link later. You don't need to copy that long URL. One caveat for WinDBG is that it's better to install it in the system drive on the root of the C drive and debuggers. It's not that it's not going to work if you don't do that. It's not that nothing is going to have any issues if you don't do that. But some of the tools are like, of the add-ons that you can add on it, the experts that you can add to WinDBG are expecting to be installed on C debuggers, so you save time on installation. Now, when you do install the other tools, you can configure them to install somewhere else, but it's just a quick tip, right? Now, when you have the 32 and the 64 bits, of course, it's better to have a different folder for each of them in order not to have some of the DLLs overwritten. But those would be like the only tips I can give in order how to install it. Enable Windows debugging C. I was working on the PPT, and that's a Spanish word for fix, right? I fixed it, I promise, but I just forgot to leave that on to clean that from the title. When we're debugging kernel mode, we need to set up the system in order to be able to do that. And some of you might be familiar with the boot INI entry that we need to modify on Windows systems that are 2003 and previous. In Windows 2008 and Vista and XP and Win 7 and 2008 or 2, we have a new way to control what system we're going to be booting. It's a local database, and we modify it with bcdedit, which is the command to modify it. I must admit that it's a complex command to use, so you do need to look into it very carefully to see what type of options it has. You can delete entries from the database. You can modify entries from the database. You can add entries to the database. Some of those entries might be overwritten by accident, so you need to be very careful when you're using it, because of course you could be breaking the boot system of your machine, right? Now, when you want to debug, the best way to do it would be to first copy the initial entry that you have. When you install the OS, you only have one entry in the BCD database, the same as you had in boot.ini. In boot.ini, you only had one entry. What I used to do with boot.ini was to copy it and then modify the entry. That's the same thing that is recommended with BCD edit. First, copy it. If you're going to do a debugging through serial port for the kernel, this is a possible entry that you're going to be using. You set up what type of baud rate you're going to have and what COM you're going to be using. Then you set the debug on. And the boot debug on allows you to debug the boot process too. So in the middle of the booting process, you can still hook the debugger at that very moment. What I usually do, and probably many of you do too, is to use virtual machines when you're working on a problem. So you can also connect to a remote machine for debug through TCP or through name pipes. So there's different options for you to configure. But this is like the one that uses the most space, so that's why I wanted to use it on the slide. Yes. Yeah, the GUI helps a lot, but you still need to be careful. That's a true note. Time travel tracing. Time travel tracing is an extension to WinDBG. This is a tool, and what I wanted to talk about in the introduction, and I forgot about, and this is a good point to talk about it, is that some of the tools we're going to be showing are available for everyone. Some of the tools we're going to be showing are available somehow for you, and they're available for us. And some of the tools are only available for us, which is Microsoft internal tools. The thing is that sometimes we're going to be asking you for certain type of traces or certain type of captures, and I wanted you to know how those help us. So if we ask you for a TTT trace, it's a bulky file that you're going to be sending us. Generally, it's in the 100 megs and above. So uploading that sometimes it's painful, and we need to set up a workspace and to upload a big chunk of data. We want you to know that that's very useful for us, right? TTT, it's one of the most powerful tools we can use. Unfortunately, we don't have something like TTT for kernel mode yet, but we do have it for user mode. And in user mode, it saves our butt many, many, many times. What it does is to set to save environment states at every single step that the process is taking. So when we load that into WinDBG as a postmortem dump, like if it was a memory dump, it allows us to go back and forth in time, to go step by step into code, to look into what's the next step, and then go back and say, what was the last step? It's a pretty powerful tool. You can see the stack at any given state, and then you advanced a couple calls, you see the new stack, and then you want to compare with the previous stack, you can just go back to the previous stack and see it. It's very, very, very interesting. We have a tool, which is the tool we use to capture. This is tttracer.exe. That is a tool we generally ask you to download. It's public. Sometimes we just send it to you. I'll show you in the demonstration. It's pretty simple to set up a capture. Once the capture is done, you're going to have a out and a run file. Those two files are the ones that you need to send to us. And you're going to have one of them for each process that you're capturing from, right? So if you're capturing from LSAS, you're going to have one for LSAS. If you're capturing LSAS and Landman server, you're going to have one for each. And those, like I said, they get very big. Just imagine that we're capturing state information from call after call after call, so they get very, very big. But whenever we ask you for this, please, please follow our instructions and do it, because this is very helpful for us. Another very good tracing tool we have is called ETW. And like most of you know, this is becoming more and more common in Windows for every component to have ETW tracing capabilities, right? So this instrumentation that's right on the code. So it helps us see how our code is doing when certain call is done, right? Or when we're doing certain operation to the server. So let's say we have a session setup, then we can see exactly how it goes all the way from the driver to the user mode and back down. So we can see all the traces. This is very useful for us in most cases. It doesn't give the detail that a TT trace does, because of course that's just a memory dump. That's everything that's in memory. But it gives us a very good understanding of what is going where, and what is going where after that, and what is going where after that. So that gives us a huge help in order to troubleshoot issues. Of course, we can pinpoint issues with ETW, but most of the time what we do is to use it as a way to narrow down an issue, right? So once we narrow it down with ETW, we can go into code or into debugging and do a much deeper job. But sometimes, and many times, issues are even clear from ETW. Basically, what it is it's a tool that I'm going to show you in the next slide. Needs to be provided a GUID. That GUID, it's something that we're going to be providing to you. The trace that's created, it's unlegible for you. You're not going to be able to understand what the trace is. It's an ETL file. We need to process it internally. We need to use the TMF files that we have in our environment and our private symbols. That creates a log. I'm going to show you the log, how it looks like. It's a text log. But if you try to open the ETL, it's not going to be of good information for you. This is a typical command that we send you. Commands might vary a little bit, more or less, but that's a typical command. So what we do is we start with the name. We provided a name. We use a GUID. In this case, I can provide the GUID through a TXT file, right? Let's say that I have many GUIDs that I need to trace, or I can modify the log instance with by adding GUIDs. But this is the usual way we provide it to you. And then at the end, we need to stop it because this is running on the background, and of course, it's taking system resources and it's creating log files, so it's going to use lots of the disk space if you don't stop it. We most of the time do it with a command line. Sometimes we do it with perfmon. Perfmon has ETW capabilities. You can enable ETW tracing from perfmon. The GUIDs are consistent across operating systems for specific DLLs. However, sometimes we need certain information, so we use certain GUIDs, and sometimes we need some other information, so we use some other GUIDs. So even though they're what we call well-known GUIDs, it's always necessary for us to tell you exactly what the GUID is, and we're going to provide you with that information. Once the capture is done, you need to send us the ETL file. Actually, the capture will create several files, so we need all the files. But the ETL is generally the only thing we really need. These are some of the so-called well-known GUIDs. As you see, we can do ETW tracing for security, for client or for server. We can go to the user mode. We can go to the kernel mode. We can do captures from almost every single component at this point. It wasn't so well instrumented in earlier versions of Windows. It wasn't not well instrumented, but it wasn't spread enough in earlier versions of Windows. But newer operating systems have this almost system-wide. So we're working with SMB here, but if we needed to work with RDP, we have ETW for RDP. If we need to work with VPN, we have ETW for VPN. We have tons of instrumentation at this point. Windows Resource Kit and sysinternals. These two are publicly available, and if you're not familiar with them, it's going to be very useful to familiarize with them. These are two sets of tools that provide tons of information that is not provided or not easily acquired through normal means with the operating system. Resource kit, I generally use the 2003 resource kit because there's tons of tools that are available on the internet to download for free from the Microsoft site. But you usually can just buy the resource kit and have, it comes with books with tons of information and lots of tools for every version of Windows. They can go all the way from telling you probably very basic information like I'm going to show you some service status, right? That you can go to services and see it, but okay, there's a command tool to do it. To provide you with the Kerberos tickets list, which is not available otherwise. You need to go into the tickets cache and grab it. There's a tool for that, which is called K-list. Server check, for instance, can give you lots of information regarding the shares of a server, right? You run server check against a UNC name or IP, and it gives you all the information about its shares and the file access information. Server info gives you tons of information about the server. We'll see a demonstration for those. Sysinternals. Sysinternals is it's a great story. Sysinternals used to be a site that was run by Mark Russinovich. Do you guys know who Mark Russinovich is? Okay, Mark Russinovich is very well known for the Windows people. He's a guy that he knew a lot about Windows. He was very, very, very deep in his knowledge. He also published a couple of books with David Solomon, which is another big entity in our Windows world. One of those books is very, very, very well known in our world, and it's a good read if you like to understand how Windows works. It's called Windows Internals. So if you've ever heard about that book, it's 1,000 pages. You're going to sleep at the third page, no matter in which chapter you start. But at the same time, when you're reading it, you're working on a specific case, if you read the book, you're not going to know what the MCPP and WSPP documents tell you, because that's very developer side information. But you're going to know everything else, which is what the system is supposed to be doing, what the administrator would like to know from the Windows side at that time. And I know that the system overview documents give you lots of insight on what the Windows system is doing, right? But when you've been working as an administrator on a Windows system, or on troubleshooting Windows systems for a long time, of course you get that knowledge. You know what Active Directory is supposed to be doing. Maybe you don't know what the bit is supposed to be doing, but you know what Active Directory is supposed to be doing. You know what the permissions are supposed to be looking like when you're setting up them on a share, on a security properties of a file or folder. The book tells you all that side. And then he wrote tons of utilities. And by tons, I try to exaggerate that. It's tons. Lots of utilities. All of those utilities are clearly written from a person that used them, which is what not usually happens, right? You have lots of commercial stuff that people just go and write them and say, yeah, this is going to be useful for everyone. And they never use them, and they don't know that they are not as useful. These are tools written by a geek that uses them very often and that decided to share them with the world. He also had some set of paid tools, right, and paid things. Now, in 2006 or 2007, Microsoft, we had a very good relationship with Mark Russinovich, and we decided to go the next step, and we bought Sysinternals. And Mike Russinovich became one of our technical fellows. So he's that's the highest technical working job you can have here at Microsoft, and he's one of them. So these tools are available from the Microsoft site now. Even though if you go to sysinternals and .com, it's going to redirect to Microsoft site. They are divided by different profiles. That would be file and disk utilities, processes utilities, security utilities. The file and disk utilities we use the most are FileMon, DiskMon, and PSFile. FileMon and DiskMon are very useful for understanding what's going on with the files in the system and with the I/O system, right? So with that, you can have lots of insight. Process utilities, Process Monitor is probably the helper every time, because it tells you information about what the registry and the files are doing from the process perspective. So you can start capturing information about a process, and you know exactly what that process is doing in registry and in the file system. A very good scenario for this is like, you have a registry key that you don't know when it's being invoked or when it's being called or if it's being modified or not. This is the best tool to do it. You just start the capturing, you start the process, and you know what the process does from the beginning to end. Process Explorer is what we call a task manager on steroids. It has tons of information about the environment. With Task Manager, you can go into the process and see some of information from the running processes. With Process Explorer, you can even see what TCP connections that process has. You can see what the stack looks like for every thread of that process. You can see very, very deep information. We're going to go through that too. Then access check, access enum, logon sessions. Those are utilities that are very useful when you want to understand what's going on with the access to a file, with the access to a share. You want to see what the ACL looks like on a specific folder or a specific file, or you want to see what services or users have logons on the system. We probably will have time to see one of those too. This is kind of what I was saying. This is basically a summary of what I just said. They can have one thing is a very, very rich filtering. You have hundreds of processes running at any given time, so you can start capturing everything, or you can just capture very, very little pieces of information, and the logs can get very, very big very easily. So it's very good to use the filters. Okay, so far, before we start with the demonstrations, we're going to have a Q&A later, but would you like me to explain a little bit more about any of the things that we've been describing?
So the time travel tracing wasn't clear to me. Are the traces that are generated, is there also a publicly available tool for analyzing those, or is that something you have to send?
Okay, so the question is if the traces from time travel trace are going to be available for you or not. Yes, those are. The tool is available for you. What happens is that you will only be able to use the public symbols, right? That information is most of the time enough for you to be able to troubleshoot the issue. When we have those traces, of course we can match those to code and we can use our private symbols. But yes, the traces are available for you. You just need to install the public version of the tracer. Okay, let's start with the demonstrations then. What I did in order to be able to demonstrate all the tools was to set up an environment on my lab machine. And I have two virtual machines. I use the same type of setting we use for the test suite. So I have a client that's a Windows 7, and I have a Windows 2008 R2 server. In order for us to be able to see both screens at the same time and stuff, I had to leave the screens smaller, so it might look a little cluttered, but I hope that it's clear enough for us to see it. So let me move this to the side. There we go. Okay, there we go. So this machine here, it's a Windows 7 client, and this machine here is a server, Windows 2008 server. So the first thing that I would like you to see is, let's start with the tools, the system internals and resource kit tools, which are the quick ones. Server info. this is the type of information that it provides. If you see there, you're going to see that it has all the way from what protocols are loaded to information about the network card, services. It's like a quick way to get information from a server. If I ask you to provide me what your environment looks like, this is a good starting point. Right? You just send this to a text file, and that's a good starting point. Let me see what other. On that time, I set up all the command lines just so I don't need to start typing like crazy. Now we can see. I don't have a Kerberos environment here, but I can show you from the other end. Let's use server check. So that gives you server check and computer name. It's very simple. So we just go with that, and we can do. And it provides you all information from the shares that computer has. This is also very useful when you're going to have a quick glance of what your sharing status is, right? What you're sharing and what permissions you're providing. For KList, I need to show you my local computer. So KList will give you what you need to enter as parameters, tickets, TGG, or you clear the cache, right? So if I go with KList tickets, it shows me what my Kerberos tickets are in my machine. This is very interesting. When you're working with Kerberos authentication, it's very common that you have a cache ticket that doesn't have the right information, and you're not having authentication, and you're fighting it, and then you use this tool. There's also a system tray tool that's called KerbeTray that also has some GUI interface to it. But this is what you most of the time need to do. You just need to know which tickets you have. If you have the wrong ticket, you just purge it, and then you move forward. Now for sysinternals tools, let's look into Process Explorer. This is, and it's going to be Process Explorer 64 because it's a 64 system. So this is what Process Explorer looks like. If you compare it to Task Manager, some of this information is very much the same. Now, when you go into deeper information, I'm going to look on the SVC host to see which one has the landman server. Network connections, remote desktop. Did that say workstation? Yeah. So once we open it, we can go for TCP/IP, and we can see if there's any actual connections and what service has them. And the threads, you can see the live information from the thread stacks, so you can go deeper and deeper into the inners of every single process that is running. This is very useful for quick glances on what some specific server is doing. And of course, in performance, it's very useful too. Sometimes you can see that a process is stuck, right? How many times did you see system consuming 50% of the CPU or 75% of the CPU or whatever? So if you go into the thread with this, you can see which thread is into the threads tab. You can see which thread is consuming that amount of CPU time. It could be that a driver is causing some kind of issues, not the system itself. So this helps you pinpoint what the real cause of the issue is. The other tool that I was mentioning, you can actually add this one as a replacement for Task Manager. There's a check that says replace task manager. And another cool thing is this one here. When you, this little target thingy, if you put it on any given window that you have, it's going to tell you which process it is. So that is very useful sometimes when you see something that's hanging, and you just drag and drop, and it tells you. Process monitor. Process monitor, like I said, it's a very helpful tool to troubleshoot registry and file access issues. Many times you're getting an access denied, and you don't know exactly where it's coming from, and this usually helps you to do that. None of these tools is installable. That's another great thing. Those are portable, so you can just run it, and it gives you the ULA every time, right? So first thing I'm going to do is to stop capturing. By default, it's going to start capturing at the very beginning. You can also capture information from the boot process. So when you have a very slow logon or slow connection at boot or login on time, this can help you out. So it gives you an entry for almost every single event that happens on the system. You can start filtering, and you can say, for instance, something like, where's my cursor? There we go. We're going to filter for process name is notepad.exe. I'm going to set include. Okay. And everything else seems to be an exclude. So let's use that one. I can actually do this. There we go. So now there's a clean window, right? If I start Notepad, I have it here, right? But it's whatever I touch from it, it's going to show all the events that happened, right? That's all that happened that that process spawned. GUI access, painting, repainting, whatever. But at the same time, if let's see that I decide to save this information for later, for ETW. Let's say that I save as, I want to save it as desktop test. And then I go to process monitor. So you had to capture a couple events, right? If you start scrolling down, you see all the reg keys that were open. This is because of the GUI interface, right? But let's stop capturing so we don't have more events. But so you have in this case, the share level. Probably, I could probably search, and it's going to be easier, but see that you have to create file events, right? Here. This is all that it's doing without me knowing. Right? I'm saving a file in the desktop, but look at all the things that happened when I was opening the windows, closing the window. So when you see something is hanging, it could be something absolutely different than what you're expecting, because you're expecting just a simple thing you're just saving on the desktop, right? But you can see all the I/O thing that the process had. And this is probably, yeah, there it is. And this is when I saved it. Probably. But it gives you all of the desired accesses, what type of I/O command sent, It's pretty powerful, gives you tons of information. Of course, you can save this one, and you can replay it at whatever time. These ones, like I said, they get very, very big. So whenever we ask you for a process monitor or something like that, or if you want to be troubleshooting with process monitor, remember to be very strict with the filters. See that only one process capture how many events? 84,000 events, right? So that's quite a bit. The details. Here it tells you lots of information about the process and what the stack is looking like. And it tells you if it's user mode or kernel mode for that specific instruction. So lots of information available. Now, what else do we have? Let's start with ETW. So like I said, most of the GUIDs that I showed before are well known. We generally use this type of way of sharing you the GUIDs and stuff. We give you a CMD file or a batch file that you run, and that sets up several GUIDs and stuff. This is the famous T command that Brian was talking about yesterday. We have lots of things preset for file sharing. We capture information from the server service. We capture information from the network layers. We capture information from many different sectors at the same time. When we have one of these traces, let's say that we have something like this. I believe this is the matching one. Let's see, 958. Yeah, this. So one of them is on the Pacific time, and the other one is on the Central time. That's why for the time difference. But this is what it looks like. This is what ETW trace looks like for us. So see that it's lots of information that's very useful, right? It gives us, in this case, the way that this is formatted makes it very, very legible. Sometimes we need to do some formatting work. This is the command file that made this text file. It's intended to do this, but it shows us, see what level the call happened, tells us exactly what happened, gives us some parameters, return errors. So let's say that I want to see what happened when I did the first session setup, right? We're expecting more processing required. So this is when we did the first session setup. And if we go to the very beginning of that line, it tells me that's 9:58:03. If you look here, I received the more processing required at 9 or 7, depending on the zone, 58:03. So it lets us match what happens on the network trace with what happens on the ETW. Some of this information, like I said, it tells us the clear issue. Some of this information says, okay, this is the area where this happens. So don't start narrowing down through debugging or whatever. Just go with this, and you're going to be fine. So this is very important for us. Whenever we ask you for this, please don't hesitate in doing it. And sometimes what we notice is that we really know if something is important for you or not when you open a case. You say, yeah, we need help with this. And we ask you for a trace, and you delay 3 or 4 days in giving it to us. We know that you're probably not that interested, but we're waiting for you. Every single case for us is very important. And that is not just demagogy or being politic. That's true. We don't deal with hundreds of cases. We deal with a small amount of cases that we pay the utmost attention to. So if we ask you for a trace, please get back. We're probably going to be able to give you the answer much, much faster if you give us the information when we ask you for it. Now, little TTT to show you how it works. I believe I got one here open. So this is a LSAS capture. We can capture some live, but I wanted to make sure that you can see something that's working. This is WinDBG. This is the interface that we were talking about. I don't know if you were at all familiar with it. This is a run that I loaded, which is an LSAS run, and this matches a network trace that I have open here. Let's do this, and then move it. So WinDBG and a network trace. What the WinDBG is doing with this TTT, see this here? This here tells us what time travel position we're at. So whenever we're working with this, let's say that I need to pass the case to someone else, I can tell him, hey, look, I was investigating, and in this time travel position, you can start seeing the stack that we were needing or whatever. If you look into this stack here, you're going to see that it says SPINIT, let's say mode context, init context. So we know we're working with a context creation here. Now, if you look at the trace, if I look to packet, I believe this one was for packet 248. Like I said, I had to prepare something so we don't need to waste time investigating, right? Most of the time, this takes us several minutes or a couple hours to figure all that out, right? So we come here, and this is session setup, right? So if I know that I'm here at this point, right, I set up a couple breakpoints with a couple functions that I know that are important for this demonstration. So I can just go, and it's going to hit a breakpoint, like if it was live. This is a capture, this is a dump, and this is working like if it was live. So this is what time travel trace looks like. We can go back and forth in time on a static dump. It's a very powerful tool. Like I said, this is just for user mode. So most of the SMB nitty-gritty happens at the driver level. So for SMB, sometimes this is not the most powerful tool that we have. But there are certain scenarios, like when we want to see what the user mode is receiving as a context, or what the user mode is receiving as a token. This is very useful for us too. In RDP cases, I know that you guys are not RDP, right? But in RDP cases, this is like, if I didn't have this, I don't know what I would do. I mean, it's very, very useful. But for user mode, this is probably the most powerful tool that we have. And now I'm on a different breakpoint, right? If I do a KB, see that I'm on the next step, right? I went all the way from LSA mode, handle up. Am I in the same spot now or not? Oh yeah, because this is the second call, probably, yes. So let's go to the next step. There we go. This is the first session setup. This is the second session setup. You can see that the stacks look very much the same. There's differences on the handle. Oh yeah, this is a different function. Yeah, handle. Which one is that one? They were certainly different. There we go. Handle challenge, and the other one was handle first call. See, so we're advancing in the process of setting up the session. Now, when we come here, we can see that now we're on the SSPR handle first call again. So the stack is moving. We're going back and forth. But now we say, okay, I want to go back. So I go G minus, and I go back. I'm on the previous stack. And this is the same for step by step. I can go T minus. I can go P minus, which are functions to go into the next instruction or into the next function. this is what it looks like. And I'm going to show you in a minute how to capture it. To capture it, we have two important commands. tttracer attach attaches to the process. So we need to see what the process ID it is. I can use Task Manager for that, right? You can just say, OK, I want to attach to LSAS. The process ID is 532. So just go with that and say, OK, ttt attach 532. This little window here, if I click Exit App, what that means is that you kill the process. Don't kill LSAS. Right? That's not a good idea. But if you uncheck the tracing on, that's going to stop tracing. But I usually use the command line option, which is tttracer stop all, because you could have many traces running at the same time. Let's say that you need to capture 5 different user sessions, right? So you can capture the information from the 5 different processes at the same time. We go with the stop all, and it's going to stop everything. Now on the same folder, you're going to have the run files. If you run it several times, you'll see this is the one that I just ran, right? But everything else has been there forever. This one is LSAS07 because it's incremental, so it's not going to override or whatever. And it has an out file. This one we need too, okay? So the run file and the out file. It's right here. So when you load that into WinDBG, you can load it as a memory dump. Open, where am I? There we go. Open crash dump, LSAS07 run, and there it is. Right, and now let's see if I didn't set any breakpoint, I press G, and it tells me that it got to the end of the trace. Okay. So wrapping up, because they are telling me to wrap up, not because I want to. So it's their fault. Okay. Okay, take a couple extra minutes, see? He's a good guy here. Good cop, bad cop. Well, actually, that's about it, right? I mean, I wanted to show you that and show you the ATW, but that's probably the last step that I'm going to take. And if you want to look into further options for WinDBG, I'm going to be available today. I was setting up, preparing another extra demonstration that wasn't on the PPTs, which is that you can also do remote process debugging with WinDBG. Of course, remote kernel debugging it's always available, right? But remote process debugging, it's very useful, especially because you can do it also through name pipes or TCP/IP. And it's what we use the most when we're working with VMs, right? Working with VMs, this is probably another very powerful tool we have. When we do live debugging, we use the process debugging. You enable a process server on one end, and then you start WinDBG with, let's do it, just 1 second. I just started, and this is a tool that comes with WinDBG, right? DBG server. So I just started it. So if I do a netstat, I can see that I have port 9999 open. And of course, I need to provide a little bit more layout. How many lines can we give it? Like, print 9999. I'm going to do it again. Oh, lots of ports open. Don't hack me, guys. Please. There you go. Probably down here. Can you see it? OK, right at the top. So I have 0000, of course, means that it's open for every single IP that I have. So now I have the the process listening to me, and I had it here, right? It's listening for me. Now, on the other end, I'm going to go on the client. And I use this command line, which is, I need to start WinDBG from the command line, remote, TCP server. Of course, like I said, you can use name pipes or other methods. And the port. When I do that, WinDBG starts, and then I say, OK, let's go and attach to a process, right? And if you look here, LSAS is process 532. Here. There you go. LSAS is here, 532. You can see, I don't know, this one here, CRSS 428, CRSS 428. So what you're looking is into the processes from the other server. OK, that's kind of what I wanted to show you guys. There's probably tons of questions. We can start with some of them now, and we can continue later if you want.
Out of time.
Out of time, OK. So quick questions or later?
Later.
Later. OK, I hope that you liked it, you found it useful, and that you understand what we do every day.